Welcome to the presentation What's New in MDA version 8.7.4. My name is Matthias Gekeler. At ETAS I'm the Product Manager for MDA. In the present video I'm going to demonstrate the new features and improvements listed here. You can find the corresponding jump marks in the description below the video. The first feature is about a new functionality for comparing signals from different files. Imagine your use case is to analyze signals from different files. You have already selected the signals from one of the files. And now you would like to compare these with signals having the same name but from another file. Instead of reselecting the new signals manually, a more comfortable way is desired. Therefore, the Configuration Manager provides a new entry in the context menu of each oscilloscope. With Select File for Comparison, a dialog opens in which the files assigned to the configuration are listed. You click on one of the entries and confirm your selection. Then MDA will add the signals from the new file to the target oscilloscope. Each signal is added to the same strip as the already assigned signal from the former file. For Boolean signals, a new strip is created just below the existing strip. To better visualize the origin of each signal, you can define a color per file. This feature was already introduced in MDA version 8.6.7. The defined color is valid for oscilloscopes, GPS maps and scatterplot instruments. But the comfortable way for the compare mode is limited to oscilloscopes currently. Moreover, you can select at the moment only one target instrument and also just one file for comparison. To compare signals from more than two files, just repeat the steps and select another file. The current limitations to one target oscilloscope and one new file will be removed with the next MDA version. Let's have a look for some special cases. In the second oscilloscope, you see that the original signal was added twice, and there is a Boolean signal in no match state. MDA will select the signal with the same name only once. This is done to keep the signal selection simple, even if multiple files are already in use. Whether the original signal is in no match state or not does not matter. If a signal with the same name can be found in the new file, it will be added. But if no matching signal is available, it will be simply skipped. For the next MDA release, such a missing signal will create a placeholder entry in no match state. In the second section, I'd like to demonstrate an enhancement for the scatterplot. Again, the use case is that signals shall be compared. In this example case, one of the signals represents a recorded signal and the other one is the output signal of a model calculation. Already in the oscilloscope, a slight deviation between both signals is visible. For a more detailed comparison, the scatterplot might be used. First, I add one of the relevant input signals of the model to the scatterplot instrument. The first added signal is always assigned to the x-axis of the instrument. Next, I drag and drop the two signals I want to compare. If this is done in combination with the Control key, the signals are copied to the target instrument. Since I dropped the signals into the graphical area of the scatterplot, a separate strip is created for each signal. As usual, the synchronization of the instruments can be used to see in oscilloscope and scatterplot the same samples. But the distribution into separate strips does not really help to facilitate the comparison of both signals. To avoid this split, the dropping should be done onto the desired target axis. Then the signals will share this value axis. Accordingly, the sample clouds can be used to directly compare the signals. Also, in case of a common axis, the synchronization allows to select in the oscilloscope the relevant time range. The color of the samples for each signal is defined by the color which you have assigned beforehand to the signal in an oscilloscope. For the identification of the samples, the respective signal name is shown in the tooltip of any sample. Please keep in mind that the representation in the scatterplot will only be meaningful if the signals have the same time basis. This is because the timestamps of the x-axis signal and of the y-axis signal is used as a link for drawing the sample point in the scatterplot. Therefore, the signals in the scatterplot should origin from the same measurement file, preferably even from the same time raster. Now you will see how special samples will be handled in the histogram instrument. When looking at this histogram, you might notice that there appears a reddish-colored bucket. This is a new feature to indicate to you samples which cannot be classified into a numeric bucket. Therefore, the bucket class is named not a number. Now I'm going to demonstrate some cases for such samples. The root cause in the first case is the conversion formula of my example signal. Typically, you are used to signals which show as physical values only numeric values. Then there exist signals for which you will see as physical values just verbal strings. Such signals are called enumerations. Now, my example is a combination of both. There is a wide range defined in which the physical value will be a numeric value. And additionally, there is for one implementation value a textual information defined. A signal with such a combined conversion is called a status string ref signal. It is used to indicate if an unusual status of, for example, a sensor is detected. And by means of the verbal information, the user can easily understand that there is a situation like error or sensor not connected. Such a textual conversion is usually defined for the highest or the lowest value range of the conversion. Thus, the signal curve in the oscilloscope will show a local minimum or maximum, and the value shown at the cursor will be a verbal value and no longer a numeric value. When zooming in so that all samples have a verbal value, you can see in the histogram that these are all counted in the NAN class. There is another case which I can demonstrate with my example signal. In the signal curve some gaps are visible. This is because there are samples which are flagged as invalid in the measurement file. This flag was introduced with the MDA V4 standard. It allows to mark samples which are already detected as unreliable during the recording. In MDA, such samples interrupt the drawing of the signal curve, even if there is just one single sample with the invalid flag. Then you should have a closer look in the table instrument. You can identify such invalid samples by the exclamation mark. The tooltip mentions the invalid state, and typically the value is shown as not available. Again, you see in the histogram that all invalid samples fall into the not a number bucket. If all samples of the currently defined time range have a proper numeric value, these are classified into an ordinary bucket. Then the not a number bucket disappears automatically. Samples which cannot be classified might also be caused by a calculation. I have defined a calculated signal which is just the reciprocal value of the input signal. But mathematics tell us that the division by zero is not defined. Therefore, the table instrument shows the infinity symbol at the respective points in time. Now I'm zooming in so that eventually just the sample with the infinity result is shown. In the histogram, this is again counted in the not a number bucket. For ASCII-based measurement files, a limitation of the supported signal data types was removed. Besides ordinary numeric signals and enumerations, also so-called status string ref signals can be part of an MDA V4 measurement file. The samples of such signals can either have a numeric or a verbal physical value. Since ASCII-based measurement files can contain only one of the possible value types, a similar approach is followed as for enumerations. By means of an option in an INI file, it is possible to define what shall be exported for enumerations. This can be the verbal string value or the original implementation value in decimal representation. Also for status string ref signals, an option is now available. As default, the verbal string is exported into the new ASCII-based measurement file. Alternatively, the numeric option can be set in an INI file. This is what I have done for one of the CSV formats defined in my example INI file. In my MDA configuration, I have selected 3 status string ref signals. The first one has in the whole measurement file only samples with the verbal value. The second one has exclusively numeric values. And for the third one, I have chosen a time range in which a change from the numeric to the verbal value happens. To reduce the amount of exported data, I used the table instrument for triggering the export. The CSV variants defined in my INI file are offered for the export. First, I will go for the CSV format, for which I have set the numeric export option. For the second export, I choose the other CSV entry for which the default setting will be applied. Now I'm loading into MDA the file with the export to numeric values only. It can be seen in the Variable Explorer that all signals appear as ordinary analog signals. Accordingly, just numeric values are shown in the table instrument. Let's check the signal which showed originally a change from the numeric value to the verbal value. In the exported file, the numeric value changes at that point with a large value change. Here, the original numeric conversion formula is applied also to those samples which could be converted into a verbal value. This is different to the numeric export option in case of enumeration signals. There, the implementation values are written into the export file. This different approach was defined on purpose. Typically, status string ref signals have the verbal conversion at the upper or lower limit of the implementation value range. When applying the numeric conversion to the whole value range, the samples with the originally verbal values will still appear as extreme values. This allows to identify such samples even if just the numeric values are available. Let's have a look at the export file using the default setting, namely the verbal values. As the sample values are now handled as strings, I'm opening the file in a text editor. As expected, the values which were shown as verbal values in the original file in MDA appear now again as strings. So depending on the use case, you should decide which of the option settings fits better. There are some enhancements for using Excel files in MDA. The support of Excel files is done in a similar way as the support of ASCII-based measurement files. To enable flexibility to differently structured Excel files, there is a separate folder for your Excel INI file. With the delivery of MDA, a folder with an example Excel INI file is provided. It explains the supported options. Currently, the options comprise the definition for the names row, the units row, and the row in which the data block starts. The time channel can be defined by the name of the time channel. Alternatively, there is a special option which does not exist for ASCII-based measurement files. You can define that a virtual time raster shall be applied to the data. Then the defined timestamp rate will start at 0 and is incremented for each following data row. To demonstrate the behavior, I have prepared an example file. First, there is an Excel sheet which does not contain measurement data. The following sheets contain the same data but are structured differently. On sheet 1 and sheet 2 a time channel is given, and there are 7 signals with a unit information for some of them. On the last Excel sheet no time channel exists. Accordingly, I have defined the entries in the Excel INI file. There are 2 aspects I'd like to mention. In the Excel INI file, it is accepted that the same row information can be given for different entries. This is the case for the names row and the unit row in the second definition. In the last definition, you can see the entry for the virtual time channel. To fit to my example file, the rate is set to 100 milliseconds. To load an Excel file into MDA, the Add button can be used. I'm using this way because then you see in the Open dialog which Excel file formats are supported. MDA will then try to interpret each sheet of the Excel file by applying the definitions in the INI file from top to bottom. As soon as a definition can be used without contradictions, it will be applied. All subsequent definitions will be ignored. If no section of the INI file matches to the sheet, this sheet will be skipped. In the raster column of the Variable Explorer, you can see that the sheet names are added as raster information to the respective signals. As usual, the time channel is not shown in the Variable Explorer. It will be handled in the background as soon as a signal is added to an instrument. In the oscilloscope, it looks as if the signals from the different sheets are identical. This is basically correct, since the signals data was the same in all of the sheets. A closer look in a table instrument shows that the signals from sheet 1 and sheet 2 are in fact identical in view of timestamps and values. Now I select the sample counter signal from sheet 3, which did not include a time channel. You can see that the virtual time channel was applied when reading the data. Therefore, the data starts at exactly 0 and then continues in the virtual time channel rate of 100 milliseconds. Nevertheless, the data matches to the entries from sheet 1 and sheet 2, but it is slightly time-shifted. Next, I will explain some aspects and advantages of an indexed measurement file. Often, measurement files are created by recording in Inca. Already at that point in time, an index can be added to the file. The index creation is activated by a user option. Please ensure that you select in Inca the option Standard for the index. Additionally, I recommend to use as file format MDF 4.1 or higher, since then the files will be compressed. I have prepared an example to demonstrate the benefits of an indexed MDF file. You can see by an overlay icon in the File Explorer if a file does not have a standard index, although the file format would support this. The signal from the file without index is shown in orange. The same signal from the indexed file is shown in blue. The major advantage of the index is a faster drawing of the signal curves in an oscilloscope. On this slide, I want to explain roughly how the index works. When displaying the samples of a signal in an oscilloscope, there are 2 limitations. One is the width of the oscilloscope, and the other is the display resolution of the monitor. These limitations cause that often many samples will fall on the same vertical pixel column. This means that the individual samples cannot be displayed separately and recognized optically. To avoid loading of samples which cannot be resolved, the amount of measurement data is reduced. To do so, just the minimum and maximum value is stored for a defined number of samples. Also, when for the pairs of minima and maxima a certain number is reached, another reduction step will be done. Accordingly, a higher level of reduction is created. This procedure is repeated until the whole time range can be described by just one pair of minimum and maximum values per signal. The entity of all the reduced data is also called index. If feasible, only the reduced data is used when drawing a signal curve in the oscilloscope. First, MDA determines the relevant indexing level. Then, for each pixel column in the oscilloscope, only the minimum and maximum values are read and transferred. Finally, the minimum and maximum values in the pixel column are drawn and connected with a vertical line. Back to MDA. The usage of the reduced data from the index is indicated by the icon at the bottom left in the oscilloscope. It is shown as long as still one signal is drawn based on the reduced index data. In my example, about 400 samples are falling onto the same vertical pixel column. When zooming in, the time range gets smaller and less samples need to be read, so the benefit of the index is decreasing. If all samples of all signals in the defined time range are read, the icon will disappear. Now I'm zooming out to the whole time range. This means the highest amount of data needs to be processed, and you can easily see the performance benefit the index can provide. The index provides a second benefit. As mentioned, the highest indexing level provides the absolute minimum and maximum of a signal for the whole time range. This can be seen in the respective columns in the Variable Explorer. When adding a signal to an oscilloscope or scatterplot, these values are used to create directly an appropriate axis value range. If your measurement file does not include or even support an index, MDA still offers the possibility to define a default axis range per signal. This can be done in the axis properties. First, you enter the desired axis range. And then you click on the star symbol in the Favorite Axis column. The defined favorite axis range will be stored in your user settings. Every time a signal with the given name is added to an oscilloscope, the favorite axis range is used as default. Also, after having modified the value axis range by zooming or scrolling, you can easily apply the favorite axis range again. By a click on the icon in the Instruments toolbar, all axes of all signals in the oscilloscope will be adapted. Of course, only if these have a favorite axis range defined. The indexing functionality can also be used independently from MDA's user interface. A new command line tool is delivered with the MDA installation. It is named MDF V4 Indexing ASAI and will create an ASAM standard conform index for any MDF V4 file format. The new command line tool can be used as post-indexing tool for MDF V4 files. For example, after a file without index was created with MDF Convert ASAI or MDF Combine ASAI. The last demonstration is about the formerly named battery instruments. Since some MDA releases, several new so-called battery instruments have been introduced. Step by step, their functionality was generalized so that these can be used now for any type of signals. To reflect this generalization also in the instrument names, a renaming was done. Additionally, the instruments support now drag and drop of signals into other instruments. As usual, by pressing the Control key, the selected signal is copied. Multi-selection of signals is possible as well. And even a bar from a signal distribution chart can be dragged to another instrument. This moves or copies the signals grouped under the respective bar. In this manner, you can quickly add suspicious signals for a closer look into an oscilloscope, for example. Just a slide, a hint about a smaller change. When using MDA, a backup file of your configuration in use is created periodically. This is done to prevent data losses in case MDA is closed in an uncontrolled manner. Additionally, MDA monitors whether such a backup configuration is not needed anymore and can be deleted. This happens, for example, when MDA is closed correctly. So far, the file extension of such an auto-saved backup was XDX. Unfortunately, when storing your files on a OneDrive share, it could happen that OneDrive assumed that the backup file was deleted unintentionally. Then OneDrive restored the backup files which were deleted by MDA to clean up the backups. To prevent in future such undesired file restorations, the file extension of the backup file is now xdx.tmp. Finally, you see here the overview of all changes done in MDA 8.7.4. For more details, please have a look into the What's New slide set. You can find it, as well as further information materials, both directly in MDA 8 as well as on the ETAS homepage. Thank you for your attention and for your interest in MDA 8.